Hi Math 2 students, and welcome to your 3.4 Day 2 Ed puzzle. So, before we get started here, let's kind of go over a concept. I'd kind of just write this in your notes somewhere. When you have a exponent that is a fraction, okay, we call that a rational exponent, and you're able to go from the power form of the expression to the radical form of the expression. All right. So let's kind of talk about that. If I had something that was like, let's see. We'll do x to the power of a over b. And you know what? Let's do it different colors. We'll do a in blue and b in red. If I wanted to write this as an exponent, okay, I'd write my radical, and this number on top goes here. So I would do x to the power of a, and then this number on the bottom, which here is my b, goes here. I would write this down. Really, all we're doing for this lesson is rearranging things. All right. So, for example, we have 3 to the 5 over 2. And all we're doing is writing this in radical form. So I know I'm going to need a radical. My 3 is going to go in there. And then my number on top, which is my a here, is going to become my new power. And then the number on the bottom goes in my radical. Now, it would be a 2 there, but if you recall, we don't write a 2 in there. That's just equal to a regular root. So it would be root 3 to the power of 5. All right. Let's go ahead and try the next one. 6. So we've got a 6 radical, and the 4 is going to be my power, and then my 3 is going to be my root. All right. Next. 5. This 5 is my power, and this 3 is my root. Here. Now, of course, it would be like 3 to the first power, but we don't really write that, so it would just be 4th root of 3. All right. So for this one, think about how we would write this as a radical, right? We'd go ahead, we'd make our radical. It would be 7 to the first root 3, but we don't write 7 to the first, so it would just be cube root of 7. Same thing for 6 here. We've got a root, power of 5, and then we put that imaginary 2 there. So it would just be square root of 7 to the power of 5. All right. So now, let's go ahead and try this one. Now we're going to do the opposite. All right. We're going from the radical form to the exponential form. So we're going to do the exact same thing. Look what happens here when we go back, right? The guy that's in the radical goes in the denominator. The guy that's associated with the x goes into the numerator. So for this one, it would be x to the 7/5. The 7 went on top, the 5 went on the bottom. Here. Now, one thing I want to point out, this to the power of 7 goes to both of these. So it should be in parentheses. All right. Oops, sorry. Got to go like that. I was writing it in radical form again. So that would be to the power of 7 over 4. All right. Notice how I put those in parentheses. This is wrong. That is wrong. They need to be in parentheses because both of those guys are being raised to the 7th power and then 4th rooted. All right. Here, think about how you would rearrange this. This should be p to the 5 over 3. This one here in parentheses, right? We got to do 2m. And then remember, this has an imaginary 2, so it'd be 3 over 2. Here we've got n. How would we do this one? We would do n to the 7 over 6. And we got this guy. Again, keep in mind, it needs to stay in the parentheses here when you've got two terms. But there's no guy on top, right? There's no power. Well, that would just be a 1. So this would be to the 1/3. All right. So do keep in mind, I guess I always remember this, like if I have like root x, that's equal to x to the 1 over 2. If I have cube root of x, that's equal to x to the 1 over 3. So keep that in mind. All right, next, it says simplify. So keep in mind, how do we multiply things with exponents? We add them. So we need to add these two exponents. 2/3 plus 1/3 is going to give me 3/3, which is just 1, right? So we'd have like 2 times n to the 3/3, which is just going to give me 2n. Next, we have to go ahead and add 1/4 and 2/3. And you do end up, if you do 1/4 plus 2/3, you get 11/12. And then, of course, you have to multiply the coefficients, so you would get 8x to the 11/12. Here, what do we do with powers? Raised to powers, we multiply them. So it'd be 3/2 times 1/2, right? You would do 3/2 times 1/2. That would give you 3/4. All right? So you would get n to the 3/4. Now, keep in mind, you could always rewrite this, right? If I said write this as a radical, well, it'd be n to the 3rd 4th root. So I guess keep that in mind, that all of these can be, you know, written as radicals. This guy would be, that would be the 12th root, which is kind of interesting. Again, when you raise, for number 16, when you raise a power to a power, you multiply. So when you do 2 times 2/3, you get 4/3, so you get n to the 4/3, which is going to give you the cube root of n to the 4th. Now we're going to go ahead and subtract. Why are we subtracting? Well, when we divide things with exponents, we subtract, right? 4/3 minus 1/3. It's going to give me 3/3, so I get x to the 3/3, which is x to the 1st, which is just x. And then again here, we're dividing things with exponents, so we need to subtract them. You know, some motorcycle just drove by my house. So we got 5/3 minus 1/2. And when you do that, you should get 7/6. All right. So you get n to the 7/6, which another acceptable answer would be the 6th root of n to the power of 7.